Hello, everybody. I'm so glad to be back, especially to be back in LA. Thank you, Side Effects, for flying me over, for giving me the opportunity to present what we do at RISE, Visual Effects Studios in Germany. So as I said, my name is Oliver Markowski. I'm CG Super at RISE. And today I'm going to present you 2 tricks to make your procedural shading workflow suck less. So number 1 trick is going to be the use of texture bombing in Houdini. And the second trick is going to be about how to automate baking of all your procedural shaders for large-scale environments and for tons of assets through the click of a button. So let's first start with telling you something about RISE. RISE has been founded in 2007. We're depending on the project load, we're between 200 and 300 people working across Berlin, London, Munich, Stuttgart, and Cologne. So I brought, RISE loves Houdini. We use Houdini since 2013, and it is now the core of our whole pipeline. We do everything comes together in Houdini. We do all the scene assembly and rendering in Houdini using Mantra. We don't use any other renderer. We don't use other scene assembly tools. We just rely heavily on Houdini, and I'm so glad we do, because it's if you know Houdini, you know that it doesn't get better. It's so good. So, and I'm going to show you right now some reels of 2 of the shows we have recently worked on, and after that we're going to get hands-on with the. Where is my Chrome? Hello. Oh, there we go. So I'm going to start with our Captain Marvel reel. If you know Captain Marvel, we built the city of Hala on the Kree planet, which is right at the beginning of the movie. Let's see if we have sound. See if it plays. Sound, please. Okay, we just look at pictures then. It's all good. So that's the city of Hala. We built the upper part of the city, and there's also a part called Sub-Hala, which is down below the ground. And this was really a massive endeavor, and it really pushed Houdini and Mantra to its limits, but mostly because we hadn't figured out a proper LOD workflow yet, so we rendered every asset was high res, even the assets 2 kilometers in the back. So that's what kind of killed us, but still we managed to deliver. So, and look at it, I think it's great. I have to say that I did not supervise this project. I have not been part of I've not been on this project. All the credits go to Oliver Schulz and his team in Berlin. So. Yeah, Captain Marvel was really cool. Really liked the movie. There we go. Thank you. Time for the second reel. And this is going to be, it's pretty big in Germany. It's a Netflix series called Dark, and it's really kick-ass. If you haven't seen it, okay, there's a spoiler warning right now, so if you haven't seen it, you're now in big trouble. But, so this is, I'm gonna skip forward because it's 5 minutes reel. I'm gonna skip the middle part. But this is something that we did in Munich, but also I did not supervise on this project because I'm on a different show right now. This has been supervised by Nicolas Loy and Dominic Trimborn, and Julia Strack is a compositing supervisor, and Sebastian Lauer is our CG Sup. So they did a great job. It's like same as on Captain Marvel. It's all Houdini, everything except for comp. But you know, hope you like it. So that's the point where I'm gonna skip forward because I don't have time. That's what we do. Thank you. So, but now back to today's topic. Hello. Texture bombing in Houdini. So you might ask, so texture bombing in Houdini is something that we're like heavily using on our current show, which is called Dragon Rider, full CG animated feature, where we had like an artist going like, nuts on procedural shading. I can't show you stuff from Dragon Rider, but I can show you something where we basically did the first proof of concepts on how to use the texture bomber in our studio, and it was a production for Amazon Studios. It was a German series, and it's called Beat, and it's also a nice series. If you wanna, if you have Amazon Prime and stuff, like go check it out. So we had two shots where we used it on. The first shot was like a huge desert where you run into trouble immediately if you want to try to use stylable textures. So I thought like, okay, this technique is so old school and it's so easy to implement. Let's just try it and try to see if we can build our own texture bomber in Houdini. So this is the final shot. I'm going to show you the breakdown soon. You'll be amazed how much we replaced, because we replaced everything. So it's like there was a truck and there was this road, and there's even the film crew standing on the side, and we just had to replace everything, and we just also put a little bit of dust behind the truck. So, and as you can already see, if you look at the final shot, and if you look at the desert, of course the stones, everything, or the rocks that are there, the actual geometry, and they of course on top help to break up the textures that are on the actual ground surface. But even if you try to look closely onto the ground surface, you won't find tiling. And this is like the first iteration of the texture bomber. It got way more features recently, which I'm going to show you real soon. And then there's another shot of the movie where we had to replace, or we had to extend a refugee camp with like all the tents. I'm going to show you the breakdown now, because that's where we shot in Malta, and there was like nothing. It's like some random location where they just shot. They just put like, how many? 10 tents, and asked us to do the rest. And in this case, we didn't texture bomb on the ground, but we used the texture bomber to place like decals randomly per tent. So you can see on those two tents, like on the lower right, you see in the turntable, like where all the dust and all the decals switch. And that's also a feature of the texture bomber where you can basically you could bomb 100 decals on the tent and then just tell the shader to just use a random 10 of them. Like you say, use 10 of those guys, and then you have a seed that you can drive through like an instance attribute, and then if you have like 200 tents, every tent with the same shader, just based on its ID, gets a different decal bombed on it. So, and this is what I'm going to show you today, how to build it, how it looks like in our studio. So, first of all, let's go for the definition. Like texture, I'm going to read this now. You can read it by yourself, but textures are useful for adding visual detail to geometry, but they don't work as well when extended to cover large areas, such as fields of flowers or deserts in our case. Such uses require either a very large amount of texture data or repetition of the same pattern, resulting in an undesirable regular look. Texture bombing is a procedural technique that places small images at irregular intervals to help reduce such pattern artifacts. The basic idea behind texture bombing is to divide UV space into a regular grid of cells. We then place an image within each cell at a random location using a noise or pseudo-random number function. The final result is then composited, blah, blah. And this is cited from NVIDIA GPU Gems, Chapter 20, Texture Bombing, published in 2004. So I'm not presenting you like cutting-edge technology. I'm just the reason why why does this guy present such an old-school technique? Because it's I have a feeling that not many people are aware that texture bombing, especially in Houdini, is so powerful and so easy to implement. It's like there is a support for texture bombing in Mari, but it's against the nature of texture bombing to then bake it out. So if you go out of Mari, you have to bake your textures, and so texture bombing is not really a good fit to do in Mari. So you can do it afterwards, maybe onto the textures you get from Mari, but I feel it shouldn't be there. So Unreal Engine has it as well. Like, and texture bombing is also like kind of big in the games already, but the way they do it, using this like just based on UV, like subdividing UV space, is not how I will present it today in Houdini, because in Houdini it's much more powerful. So just a show of hands, who's using texture bombing? 1 out of 2 out of 80 maybe, or 70. So I thought, I was expecting that, and I'm glad that not everybody raised their hands right now, because then this presentation would be useless. But and yeah, I have to say that Houdini is especially good for this technique, because there is no other package out there where you can, from within the package, generate a point cloud, and from within the integrated renderer, like Mantra, read this point cloud and do stuff with it. So you can't, of course, you could create points in the other DCCs that I don't like anymore. And then there are like renderers where you would have to find a way, like what format would you bake a point cloud to? Would you use Alembic or a VDB points? And then you have to ask the Arnold guys or the V-Ray guys to build you something where you can read it's just not working. There is no out-of-the-box support in any other DCC. And this is where, again, I'm so glad to be using Houdini in production, and we're not missing many features. And with the release of like Solaris and Karma, I'm even more happy that we are already on Houdini, and so it seems the future is very bright. So quick shout out, there's one guy who already tried to kind of advertise texture bombing, Sean Lepowski. He it was a part of a workshop that he sold over at CG Society. It's called Vex in Houdini. It's kick-ass. It's really kick-ass. It's not just texture bombing in there. There's so much cool stuff. So I don't know if you can get like past versions of it, because the current iteration of it is not run by Sean anymore. It's somebody else, and I think I looked it up. It seems they don't have texture bombing in it anymore, but you don't need it because I'm going to do it today. But nevertheless, like Sean Lepowski was one of the first guys doing this and presenting this, but somehow it didn't take off. Maybe SIGGRAPH is a better audience to present it to. So hopefully it will find more use in the future after you've seen it and after all the guys on YouTube have seen it. So let's see how it goes. So another show of hands. Who knows Vex? Cool. You're my audience. And of course, everybody else wants to learn it, I guess. So let's go hands-on now. I hope nothing crashes. But I've been lucky the last couple of days with my MacBook. So, okay, that's a good start. Okay, here we go. So, we are texture bombing right now. So, just a quick overview. So, this is what a UV space looks like if you use tileable textures. Okay, you see the tiling already. So, but I've created this tiling using the texture bomber already, but just without all the tricks that you could apply. So what you see here is just a lot of points on a regular grid, and the points are not distributed randomly, they're distributed evenly. But if I play forward, you can see that I'm just moving the points now. So now I have like a random position for those guys already. So, and if I now go to the render view again and hit render, hopefully it will start, you see that those guys have not just moved, but they have like an attribute on top, which tells the points to also rotate. So, okay, first things first. So this is the result after the first iteration of texture bombing, just showing you a UV grid, like how the grids moved from like a regular tileable grid to a totally random distribution. So that's the UV gradient. So let's check out with the texture map. So, and after you've seen it with the texture map, you will say, that's nice, but it's still like rectangles. It's not very nice. Like, you will still see some borders here and there. So, of course, in this case you see it, but there's one trick that it's not even a trick. It's obvious. Like, you just, instead of using RGB textures, you put an alpha on it and use the alpha as a mask. So if I switch to RGBA, never mind the color change, it went from JPEG to red, and the red was already in linear. So here you can now see an organics alpha that I created by myself, like artistically in Nuke. I just used this texture came like with diffuse and depth, and I just graded the depth a little bit and did some roto on it and came up with some nice organic alpha. So you won't see, like, the human eye won't see any straight cuts and nothing, nowhere. So, and to fill this up, you just crank the number of points that you want to bomb. So if you then go to a much denser point cloud, you will just see that it's kind of watertight now. There are still a few little holes here and there that you could just fill up using a old school tileable texture. So the output of the texture bomber is RGB, alpha, and then there's a combined vector 4 output that has all of the 4 together, RGBA. You need this if you want to stack one bomber over the other but I'm not going to talk about that today. So let me just show you the output of it. So that's the actual HDA. You can see the outputs, and you could basically just use a regular tileable texture to and mix it under what has not been covered by the texture bomber. So you could, of course, add more points, but at one point you will get tired of putting points at the very last edges. So at one point you just say, go put a tileable texture below there and be good, be done with it. So so you could still see, since this is just a single texture bombed, if the texture has like some in this case dark areas, they might be noticeable. Still, they are like rotated and scaled randomly. It could be even real, but so I'm gonna show you all the parameters of the HDA right now, because there's like the first parameter you find on it is, if I don't connect it, so it's not grayed out, it's the texture map that you want to use. And of course you need to tell the HDA what texture to bomb, but it has a specific option which says use frame range. And if you would have, you can put like a %04D in here. And later on, I'm going to show you all the VEX code, but you could basically substitute this little %04D by a frame range and just tell it where your sequence starts and where it stops and what seed you want to use. And so you could basically also use a sequence for bombing. So, and then you're going to get rid of any visible tiling like once and for all. So then there's just a small checkbox, but it's very powerful, because like the old school texture bombing guys from NVIDIA that presented the technique for the first time did, like they subdivided the UV space. But in our case, we have like large scale environments that I don't want a UV. I don't want UVs. I just want my points, and then I want to say like how much area would one like patch of a bomb patch take, and I want to have all my UVs be triplanar projected. So the texture bomber is able to just figure out what is the best angle to project from. So, but these are all features that came later, and this is an ongoing HDA for like a year now, or maybe even longer. So this texture bomber doesn't need UVs; it just needs points, and then you toggle the triplanar button, and it's all good. So I'm going to show you the VEX code later. So I'm just going to run through all the parameters first. And of course, you need a point cloud file. In this case, it's just a channel reference up to the point where I created it. So I'm going to show you real quick, because I don't even have to show you. You're all old school. You're Houdini guys, right? I don't need to show you. Come here. No. Scene view. Here we go. So there's just my plane or whatever object you have. Then you just scatter points on it. And what did I do? That's another thing I'm going to show you later. So in this case, the first one was I just jittered. I animated. Come here. Won't show you. Ah, no, it shows you. So this is just a grid that I just jittered and added a few attributes, like for the rotation. So the texture bomber is able to find in the point cloud an attribute that's called bomb rotate. If you put that in SOPs, like randomly, it can pick it up and use it as to rotate the UV space around the point that you bumped onto. And then of course it uses p-scale. There's a toggle for that, to use p-scale or to not use p-scale. So you can beforehand artistically decide how your the orientation of your textures is going to be and how the scale of your texture is going to be. If you do it like on the geometry, and if you have like vertex attributes, you have to make sure that you vertex split afterwards based on, in this case, UV. So they, all the attributes that you had on vertices before need to go to points, because it doesn't read vertex information. So, and afterwards, I'm just going to I'm just killing all the geometry so that there are only points left. Then I just rub that out. So you see, I used already an animated sequence of points. It's not limited to like a single static point cloud. You can use it even for, if you do FX, like let's say gunshot decals across a wall or whatnot, your FX guys can just give you an animated point sequence, and you then just randomly put impact decals on each point. And you can, of course, using this frame range that I just mentioned, you can even vary those decal textures so they don't look the same. So good thing is I have something else prepared, and that's more or less what I was just talking about, the decals on the wall. I'm not going to use decals in this case. In this case, I'm going to use little arrows to show you like how you can even artistically drive how the orientation of the points is. For some reason, those fuckers go into the wrong direction. I've used the polyframe and created the tangent, like the tangent for each point, and the tangent looks right in the viewport, but for some reason the texture bomber misinterpreted that. But most of the time you can see that the arrows point in the right direction. I don't know, it's less for this presentation. I was too lazy to figure it out, so what happened. But you can see, you can even art direct the orientation of the points. So yeah, that's just one thing I wanted to show you. And if I step a few frames back, this is like also an animated sequence. You see that this is still working. So yeah, you can animate it. You can animate the rotation. You can animate anything. So good. What's next? Now I need to figure. So I showed you how to create points, which is not that big of a deal in Houdini. And we have seen here the render view. Let's see what we have. I showed you all the desert stuff. So I think, I know we were still at the, like, going through the parameters. So let's just go back there. So where were we? So triplanar is covered, point cloud is covered. And then there are multiple options to how you want to look up your point cloud. So if you want to look up your point cloud in world space? Do you want to look it up in object space, in UV space? UV space would be like the old school 2D way of doing it. But and then there is also the possibility to use a rest position. If you have an animated character, you could even texture bomb on this animated character, and then just look up, do the point cloud lookup using rest position. So, but that's, yeah, you know all of that. I know that. So then, this is what I mentioned earlier with all the tents. For those tents, I scattered a predefined amount of points where I want my decals, but then I told the shader to just use. Let's see if this works. No, let's see if this works. If I dial it down like that. And hit render again. Yeah, of course this doesn't work. Let's see. Oh, okay, no, let's make this quick. So usually that works, and it just randomly picks a few, just a few of those points. Maybe that was the reason. Of course, it now works. Okay, cool. So you see, I dialed down the amount of points to use. So it just uses this amount of points, and then I can also, the offset is unfortunately in a different. Come here. Should be using different points. Yes, it does. So you can just use different points. And this is something you could drive through another attribute that sits on your packed prims. So you can just, for 100 tenths, have the ID from 1 to 100, and just also drive the amount of points to use, and also the seed for it. You can also just give it a different seed. So we're almost out of time already. It's like 17 minutes left. I'm gonna hurry. So bump scale, okay, multiple by p scale. That's all stuff that you might be aware of. So this is, if it finds p-scale on the geometry or in the point cloud, it's going to use it. It's going to use a bump rotate attribute that I just showed you that was created in subs. If you don't have that, you can still randomize the rotation even without an attribute present, because you still have the point number in the point cloud that you can do some random stuff on. So you don't need to create a rotation attribute in subs before. You can just do it here. So there's a seed, of course, and a little offset to globally offset stuff. And that's it for the parameters. This is legacy stuff, and this is future stuff. Because I'm about to figure out a way to how to texture bump on large-scale environments without a point cloud. Because sometimes even that is a bit tricky. Like we had like a Grand Canyon scale environment, and even like scattering points on the high-res geometry was kind of slow. It still worked, and this texture bombing and like point cloud lookups in Houdini are super fast. No matter how many millions of points you have, they are really optimized for speed, and so you shouldn't be afraid of using 2 million points for texture bombing. It's easy. You can maybe even use 20. It's really kind of fast. So I would say let's just look at the code. I have to apologize. No, that's the wrong one. Because, like, usually this should seem like just a few lines, but somehow it exploded because of all the features we put in later. So if you like do a basic implementation of texture bombing, it shouldn't be more than 20 lines of vex. I can also show you in. Oh, this one. So if you want to look it up, just Google texture bombing and then find the link for the NVIDIA developer zone, because that's their old school texture bombing. You have to replace the point where they find like the random point, or the where they do the UV. You have to replace that with the point cloud lookup. But basically, this is how they would do it in 2D. This is like the most basic approach to texture bombing, and it's even got code. You just have to replace everything that says fixed or float or whatever with vector. That's like you can replace everything with vector, and it's going to be all right. So except for fixed 4, you have to replace that with vector 4. Maybe you didn't even need it. Whatever. Like check this out. This is like the super basic implementation, and this is the not so basic implementation, because there are plenty of things, like all the options, like what's the lookup space. So if you start with this, there it already starts. Like if you look up in UV space, you want your transformed shading point to be the UV coordinate, but most of the time I don't want the shading point is the vector that you use for the point cloud lookup. And if you do the lookup in the point cloud, for example, here, if you don't look up against P in the point cloud, but if you want to do it old school and you look up against UV, then basically your lookup point has to be the UV coordinate that you're on at the moment. But yeah, what do you do? So imagine this grid that you just saw, and imagine we are in world space. So what we do is we take our current shading point, P, from the renderer, and transform it using PD transform from the current, which is camera space, to world space. And this is now the shading point transformed. That's because why it's called transform shading point. So using this point, we ask Houdini to open up the point cloud, that's the name of the actual point cloud, like the BGO, whatever. That's the attribute you want to look up against. And this is like the point that the renderer is currently sampling. Then there's the lookup distance that I've defined earlier. I'm still not sure what a good value is, but it's like, to me, it seemed like the scale of the texture should be sufficient if you do it by 2, but it sometimes doesn't work. I don't know why. And then you have to tell it how many points it should look up. And this depends, like usually it's enough to look up 1 point, but then if you have overlapping textures or points that are too close to each other, you might want to look up more, and that's why I put it on the HDA as an option, because sometimes 2 is enough, sometimes you need 3. It's like, it just depends on what the renderer gives you if you need to crank it. So then here comes triplanar stuff. We're so short on time, I'm gonna skip it, because that's definitely something that will break me in time. So here I'm gonna create some variables. First of all, we need the position of the point that the point cloud lookup gives back to us. Then sometimes we need the UV from that point as well, if we don't use the triplanar version of it. Then of course we need the bomb rotate and the P scale. We may need it. Then we need the point number, because the point number in the point cloud is important, because you need to say which decal has priority over the other. So in my case, I said like the lowest point number wins, or is the highest? I don't know. I think the highest point number wins. Like whatever the point number is higher will be on top. It's like the layering, more or less. Then there are some intermediate variables that we need, and this is where we actually start. So now we iterate over the points that the point cloud call, the PC open call, gave us. Then we initialize some variables to 0. And first of all, for like the layering, we also get us the point number from the point cloud file into the variable called ptnum from point cloud. So now we in here there's a random number that is that's generated from the point number from the point cloud and the seed for the. This is basically if you don't want to use all of the points, the use point decides if the point will be used or not, if it's skipped. Like if you say I only want to use 50% of the points, if I find that this point is not a valid candidate, I'm not going to do any other calculations, and I'm just going to skip over this point. And then there's this frame range thing. So if you want to bump on, if you want to use a texture sequence, what you do is you basically take the string that was in the bump map, and just since there is already this %04D in the string, you can just run it through sprintf, and it will format the integer that you have just calculated here and replace it inside of the map name. So this is basically the map that is going to be used in this iteration on this point of the point cloud. So then we go away from triplanar. We don't do that. So sometimes, so if you don't use triplanar mapping, there will always be UV coordinates needed. So I'm gonna check against, like if we use triplanar, we use just the P, the world position, as a UV coordinate, or otherwise we use the UV coordinate that's also stored in the point cloud. So, and basically this is where we calculate our new UV map, or the ST map basically, that we use for the whatever texture we need. It's just basically looking at the UV coordinate we are at the moment in the, like, for our current sample, and then we just subtract the UV coordinate that we got back from the point cloud. So we have a UV grid centered around the point from the point cloud that we just have sampled. So this gives you an unlimited zero, or like from minus infinity to plus infinity, but you just have to clamp this vector, or this those coordinates to 0 to 1. Let's see where I do that. Okay, here comes the tricky part. Like, after you have your first set of your first UV space, more or less, then you can decide on how much you want to scale this and how much you want to transform this. And this is what comes next. First we ask the point cloud if we have a bomb rotate attribute present. If yes, that's true, and also if on the HDA, if it's enabled, then we look for it, and if we have found the thing, then we fill in this rotation value into the variable called bomb rotate. And at one point, I'm gonna speed through this a little bit because we're really close to be done. So here we add the p-scale. So I think on YouTube you can follow this with a little more time. You see all the source code in here as I scroll down, so it's going to be on the recording. So feel free to try to replicate it. So what I do, like, to rotate the stuff, you just call, you build a rotation matrix, then you say rotate by those degrees that you have found in the bomb rotate attribute. Then you scale the UV space, and then after that rotate it. Then we have to skip triplanar again. And then here you ask, are we between 0 and 1? Because as I said, the numbers you get from just subtracting one UV by the other might be over 1 or below 0. And if you're inside of there, then there's the actual texture lookup, finally, that looks up the texture map at the UV coordinates that we have just calculated. Here's some debug stuff that you not should be interested in. Then there's another interesting thing I just learned about ordering arrays in Houdini, because I'm filling up an array because of the layering of the different decals. There is a way to do it. I tried to do it easier beforehand, but with all the triplanar stuff coming in, I refactored all the code to just store every RGB and A information that I found for every point from the point cloud I got into an array. And then afterwards, after I ran through the point cloud for the first time, I then just ordered all those arrays again based on the point number. And then you can always skip the debug if you want to, like, replicate the code. Just get rid of this. The debug is just for me, because there was tons of debugging. You have no idea how hard it is to debug such a thing. And so in the end, it's just running over the arrays again with all the RGB information that you have stored, and reorder it and just composite one over the other. That's it. And at the very end, that's the color we return. That's the alpha we return. And so that's like the the professional version of texture bombing. It's really hard to describe in such a short amount of time. But like if you really want to get started on it, try the simple one first, then rewind this on YouTube, what I just told you, and follow the code and try it for yourself. I really encourage you to give this technique a shot, because it will really, really help you speed up your workflow. You don't have to go through Mari to use texture bombing anymore. You don't have to use noises to blend one tileable texture to the other, because you will always see the non-organic nature of CG noises. So this stuff basically has no CG noise involved, because like the textures you use from photographs and the masks you extract by maybe using the depth channel or whatever you get with the, like if you for example go whatever texture library you use, you get the diffuse map, and you usually also get a height map. So there is no or not many CG noises involved in this process. The only CG part is maybe the distribution of the bomb points, but that you can even paint the distribution. So there's basically you can get away with using without using any procedural noises, which always tend to look CG in the end. So thing is, I think, to be honest, I don't have time anymore. We can do like a quick Q&A, but there was a second part of this presentation, like the trick number 2. I'm gonna make this. Let's do Q&A on texture bombing first. Questions? I know it was fast. I know it was. You might not have gotten into every detail, but throwing it. Should I throw it?
I'm the volunteer. Sorry.
Come again?
Oh, I'm the volunteer for the. Yeah.
Cool. So questions?
How hard would it be to do this with another renderer?
Yeah, there we go. That's what I told you guys at the beginning. I think it's like code-wise, that's an easy thing. You just need functionality in Arnold or V-Ray to read point clouds. Like you need a call for, like you, of course you can write your own Arnold shader, of course you can write your own V-Ray shader. As long as you have a call to do a point cloud lookup, you're good. And you could even use the same code, because Vex is C++, it's like copy-paste. You could do it. But I have no idea on how easy it is to do point cloud lookups in Arnold, for example, or in V-Ray. I don't know. But it's doable. It's not Houdini only, but what I want to say is, like, guys, stick with Houdini. Karma is coming. You don't want another renderer. It's all good. Yeah. But it's doable, yes.
Is this?
It's not working. I understand you. I'm going to repeat the question.
It's not working?
No,
okay,
it
there it
works.
is. I was curious about your. You were saying you wanted to do it without point clouds. So what were some of your ideas behind trying to do that without point clouds?
So to be honest, the first time I checked this out, like this easy stuff, was like yesterday, because I just wanted to see how they do it, and there was so if I did the pointless mode that I had in mind in the first place is like, I just store a pre-baked point cloud, like in a unit box with 1,000,000 points somewhere, so where the artist doesn't see it. And if you click on pointless mode, this pre-baked point cloud gets scaled onto basically the world position, or like the world position that you look up against could also be divided into those regular grids like they do in 2D, and then you just do a lookup into the unit box into your predefined point cloud. So that it's something that could be done. But what they do is like the 2D grid lookup. You could even do like a lookup in like the cube. I don't know how to say it. I'm German, man. I'm not a native English. It's like you could do it on a regular grid as well, but a 3D grid more or less. So you take those, like the closest point that would be in this grid, and then do like a fixed offset based on the cell ID more or less where you're in. So that could be something that might work.
Interesting.
Over? I think we're done. Talk to me outside. Cool. So I think I'm going to come back to present trick number 2 next year. Thank you very much.